Hello guys, and welcome back to the channel and welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. And today is day 73. We'll be learning consistently over the past 70 plus days. So we're on the course called Sampling in Python, where we got introduced to what sampling is in Python. So on the last live stream, we learned all about what sampling is, why it is so powerful. We also learned about the difference between true randomness and pseudo randomness. So in today's live stream, we're going to the chapter 2 of the course, which is sampling method. So we're going to get introduced and know more about the different sampling methods like simple sampling, systematic sampling, stratified sampling, and cluster sampling. So welcome back. So without further ado, let's jump back to the learning and get started on this new chapter called sampling method in Python. Also, the data set will be linked under the description so you can practice your sampling skills in Python and get your hands dirty. Without further ado, let's jump back to learning. So this was the last time we learned all about sampling in Python. So randomness sampling and pseudo randomness sampling in Python. Okay, so let's say what is sampling method. So we have simple, systematic, stratified, and cluster. So we have all of this to cover by the end of this live stream. Let's get started.
There are several methods of sampling from a population. In this video, we'll look at simple random sampling and systematic random sampling. Simple random sampling works like a raffle or a lottery. We start with our population of raffle tickets or lottery balls and randomly pick them out one at a time. In our coffee ratings dataset, instead of raffle tickets or lottery balls, the population consists of coffee varieties. To perform simple random sampling, we take some at random, one at a time. Each coffee has the same chance as any other of being picked. When using this technique, sometimes you might end up with two coffees that were next to each other in the dataset, and sometimes we might end up with large areas of the dataset that were not selected from at all. We've already seen how to do simple random sampling with pandas. We call .sample and set n to the size of the sample. We can also set the seed using the random state argument to generate reproducible results, just like we did with pseudo-random number generation. Previously, by not setting random state when sampling, our code would generate a different random sample each time it was run. Another sampling method is known as systematic sampling. This samples the population at regular intervals. Here, looking from top to bottom and left to right within each row, every fifth coffee is sampled. Systematic sampling with pandas is slightly trickier than simple random sampling. The tricky part is determining how big the interval between each row should be for a given sample size. Suppose we want a sample size of 5 coffees. The population size is the number of rows in the whole dataset, and in this case, it's 1,338. The interval is the population size divided by the sample size. But because we want the answer to be an integer, we perform integer division with 2 forward slashes. This is like standard division, but discards any fractional part. 1338 divided by 5 is actually 267.6, and discarding the fractional part leaves 267. Thus, to get a systematic sample of 5 coffees, we will select every 267th coffee in the dataset. To select every 267th row, we call .iloc on coffee ratings, and pass double colons and the interval, which is 267 in this case. Double colon interval tells pandas to select every 267th row from 0 to the end of the data frame. There is a problem with systematic sampling though. Suppose we are interested in statistics about the aftertaste attribute of the coffees. To examine this, first we use reset index to create a column of index values in our data frame that we can plot. Plotting aftertaste against index shows a pattern. Earlier rows generally have higher aftertaste scores than later rows. This introduces bias into the statistics that we calculate. In general, it is only safe to use systematic sampling if a plot like this has no pattern. That is, it just looks like noise. To ensure that systematic sampling is safe, we can randomize the row order before sampling. .sample has an argument named frac that lets us specify the proportion of the dataset to return in the sample, rather than the absolute number of rows that n specifies. Setting frac to 1 randomly samples the whole dataset. In effect, this randomly shuffles the rows. Next, the indices need to be reset so that they go in order from 0 again. Specifying drop equals true clears the previous row indexes, and chaining to another reset index call creates a column containing these new indexes. Redrawing the plot with the shuffled dataset shows no pattern between aftertaste and index. This is great, but note that once we've shuffled the rows, systematic sampling is essentially the same as simple random sampling. Let's get sampling.
Okay, so let's see what sampling, random sampling is. So simple random sampling. So the simplest method of sampling a population is the one you've seen already. It is known as simple random sampling, sometimes abbreviated as SRS, and involves picking rows at random, one at a time, where each row has the same chance of being picked as any other. In this chapter, you apply sampling methods to a synthetic fictional employer attrition dataset from IBM, where attrition in this context means leaving the company. So we need to load the dataset. So attrition population is available. Pandas as speed is loaded. So let's load our attrition datasets into my own Jupyter notebook here. Just go ahead and create a new notebook. I try to rename it. I can actually just copy it from there. Just rename this one to sampling Python 2. So if you have that rename successfully here, so I'm just trying to make sure my live streaming is giving the good results. So I want to copy all these libraries that we use here. I always make use of. I made the line of code. Then I'm going to read the data sets. So our data set in this instance is a feather file. I'm going to go into my so we have our attrition data here. Let me just edit this line of code to attrition. So the data set is an attrition of a fictional company. Okay. So what should we call the data frame? Data frame is called attrition population in this instance. Let me just call it attrition population also. If I show on the line of code, okay. Let's look at attrition population and voila. So these are our data set we want to work with. We just have 1,400 rows of data and 37 column. So we have the age of the employee, the attrition, the business, travel, daily rate, departments, distance from home, education of the employee, education field, environment, satisfaction, gender, performance rating, a whole lot of metrics here. Let us just do attrition dot head. To only return a few rows of column. And let's get back here. So it says, let me just refresh this page. So the instruction says sample 70 rows of data. Some 70 rows from attrition population using a simple random sampling, setting the random seed to this figure here. So we want to sample the attrition population. So we're going to say attrition population dot sample. Let's sample 70 rows. Let's sample 70 rows. Then we set the random states. Random states to this figure here. Say print. Let's see what we have here. And voila, I can see we have these rows, just 70 rows and 31 columns have been sampled. If I copy this line of code and make use of it here also, let's see. And voila, we have 70 rows, 31 columns. These are random rows actually selected. Can you do attrition dot head just to make it easy? Voila. So that's the result we want to get there. So let's submit our answer and see. We nailed it. Notice how the indexes in the sample aren't always in increasing order. They are just random. Exactly. We look at the indexes there. These indexes right here, there's random rows of data selected from our sample population. So systematic sampling. One sampling method that avoids randomness is called systematic sampling. Here you pick rows from the population at regular intervals. For example, if the population dataset has 1,000 rows and you wanted a sample size of 5, you pick rows 0, 200, 400, 600, and 800. Okay, so let's do the same thing and see how it looks like. Set the sample size to 70. Going to set the sample size to 70 this time around. Same thing we did earlier. Then calculate the population size from the attrition population. That will be the length of the population of attrition population. Then we need to calculate the intervals. That should be the population size, pop size, divided by the sample size. That should give us our results. Okay. This is systematic sampling. Let's say using should be using systematic sampling. Set the sample size to 70. So we've done that. Now, systematically sample attrition population to get the rows of the population at each interval, starting at 0. Assign the rows to attrition system sampling. Okay. Now we need to systematically sample 70 rows. How do we do that? So I want to use the iLock method. I'm going to sample this attrition population dot iLock. Yeah, this is the live video side. This is the live stream. Yeah, I can hear you. I can see your comments. Oh, can you hear me? So let's see. And voila, we have 70 rows, 31 columns. These are random rows actually selected. Just having a quick peep on my quality of video. So we need to now we need to systematically sample. Hey Said, I can hear you. So this is a live this is a live video. Yeah, this is a live video. This is a live stream. I'm finding it hard to reply to your chats. Yeah, just spamming my comment section. I'll probably have to remove you. So I just have to move on. Someone is spamming my comment section. So now we're using iLog to systematically sample attrition population. So I'm just going to use then at interval. So let's see. And voila. You can see the interval has been specified for us. And let's try the same scenario here. So I'm just going to sample 70 rows of vacancy. So same scenario, same idea, just different results. So this, so that's sampling. That is systematic random sampling. So systematic sampling avoid randomness by picking rows at regular intervals. So that is the difference between simple random sampling and systematic random sampling. Let's continue learning. Is systematic sampling okay? So let's answer the question. Is systematic random sampling okay? So systematic sampling has a problem. If the data has been sorted or there is some sort of pattern or meaning behind the row order, then the resulting sample may not be representative of the whole population. The problem can be solved by shuffling the rows, but then systematic sampling is equivalent to simple random sampling. Here you look at how to determine whether or not there is a problem. So add an index column to attrition population, assigning the result to attrition population. So we want to add an index column to our population. Oh, so we need to add a new column to this our. It's going to be attrition dot reset underscore index. Close and open the brackets. Then we're going to create a scatter plot of years at company versus index for attrition population and using pandas. It's going to SNS the scatter plots. So our plots, our kind is going to be, so there are different ways to add the scatter plots. So I'm looking for the best way to do that. Create a scatter plot of years at company versus index for attrition population using the OK. So we're going to extend the scatter plots. Our data is going to be this our attention population ID. Our X is going to be the index, this index column. Our Y is going to be the years at the company column. Yeah, the company column. So that's pretty straightforward. Let's run the code and see. Oh, I mean, it's a resonate, the scatter plot is not defined. Let me run this line of code here and see if I'm going to get a good result, rather. We should have an attrition population. If I call on this now, let me see. Hold up a minute. Let's call on this our attrition population. Well, I should have a new column called population ID. Do we? Let me run this line of code and see. Voila, see our results here. You can see the attrition population based on the index. So I actually make use of the index column that was here. But I can't find the index column in my line of code here. So I should get these similar results. Okay, let's give it a shot again. You see, I've not imported SNS. So in this instance, I have my SNS imported here, Seaborn imported. So I'm making use of Seaborn. So another alternative is to make use of, well, let me check. Using the attrition population ID. So let's make use of that. And let's get rid of this. Let's make use of this. Okay. Let's run the code and see. Well, so we have similar results. You can see I have similar results, just like what I have using Cborn. But let me copy this line of code and give it a shot again in this place. What I use here is using the attrition population dot plot. This attrition population ID created here. Let's see, we're going to get the same results. But like I said, we got similar results. We're actually using the old data set, this attrition population ID, even from here, and we still have similar results. 0 to 5, 0 to 1,400. You see, just a little bit difference in the number of rows that we have here. Interesting. So randomly shuffle the rows of attention population ID. So let's do random sampling for the rows of attention population ID. Shuffle the rows of attention population ID, attention shuffled. Randomly shuffle the rows of attention population. How do you do that? Okay, we need to shuffle it. So I'm going to use the additional population data. Then we'll call on the dots sample method. And we say the fact equals to 1 to do random shuffling there. I'm going to reset the index, reset the row index, and create an index column. Attention shuffle equals to attention shuffle dots, which will set the index. Okay, let's see. So reset index. Reset index. So I'm going to drop the index. Dot reset index also. Now close the brackets. I want to plot year as company versus index for attention shuffled. Okay, repeat the scatter plot of year as company versus index, this time using the attention shuffled. Let's repeat what we did here also. And see the results. I want to use this attrition shuffled data. Okay, hands crossed. Let's run the line of code. And voila, see what we now have here. Interesting. Let's see it in real time in my Jupyter notebook here also. Okay. Then we run the line of code and voila. And see the one we shuffled. So these are absolutely random, making systematic sampling safer. So we are going to get another result entirely. Okay. And finally, does the systematic sample always produce a sample similar to a simple random sample? No. Yes, all sampling random or non-random method will lead to similar results. I doubt. We don't use seed. So sample scales are ample. Systematic or contain a pattern. Shuffling the rows make it equivalent to simple random sampling. Shuffling the rows makes it equivalent to simple random sampling. So when you shuffle systematic sampling, you're even making it equivalent to simple random sampling. So what is now the best option? Okay, let's continue learning. So we'll be able to replicate same lesson that we did here in Jupyter Notebook here. Interesting. Okay, let's look at stratified and weighted random sampling.
Stratified sampling is a technique that allows us to sample a population that contains subgroups. For example, we could group the coffee ratings by country. If we count the number of coffees by country using the value counts method, we can see that these 6 countries have the most data. To make it easier to think about sampling subgroups, let's limit our analysis to these 6 countries. We can use the .isin method to filter the population and only return the rows corresponding to these 6 countries. This filtered dataset is stored as coffee ratings top. Let's take a 10% simple random sample of the dataset using dot sample with frac set to 0.1. We also set the random state argument to ensure reproducibility. As with the whole dataset, we can look at the counts for each country. To make comparisons easier, we set normalize to true to convert the counts into a proportion, which shows what proportion of coffees in the sample came from each country. Here are the proportions for the population and the 10% sample side by side. Just by chance, in this sample, Taiwanese coffees form a disproportionately low percentage. The different makeup of the sample compared to the population could be a problem if we want to analyse the country of origin, for example. If we care about the proportions of each country in the sample closely matching those in the population, then we can group the data by country before taking the simple random sample. Note that we use the Python line continuation / here, which can be useful for breaking up longer chains of pandas code like this. Calling the dot sample method after grouping takes a simple random sample within each country. Now the proportions of each country in the stratified sample are much closer to those in the population. One variation of stratified sampling is to sample equal counts from each group, rather than an equal proportion. The code only has one change from before. This time, we use the n argument in .sample instead of frac to extract 15 randomly selected rows from each country. Here, the resulting sample has equal proportions of 1/6 from each country. A close relative of stratified sampling that provides even more flexibility is weighted random sampling. In this variant, we create a column of weights that adjust the relative probability of sampling each row. For example, suppose we thought that it was important to have a higher proportion of Taiwanese coffees in the sample than in the population. We create a condition, in this case, rows where the country of origin is Taiwan. Using the where function from NumPy, we can set a weight of 2 for rows that match the condition and a weight of 1 for rows that don't match the condition.
Larger group. Oh, we're still going to change some stuff. Oh, we know it's super easy. So now we understand the difference between stratified sampling and simple random sampling. Okay. So we're looking at stratified sampling. Remember here groups is used for what? Group sampling. So that's how you get it. So if you care about your subgroups, otherwise simple random sampling is more appropriate. So classic classification. Stratified sampling is useful if you care about subgroups. Otherwise, simple random sampling is more appropriate for individual sampling. Now let's look at what are we going to try to solve here? Proportional stratified sampling. So our last one is cluster sampling. So let's answer this key question here. So if you're interested in subgroups within the population, then you may need to carefully control the count of each subgroup within the population. Proportional stratified sampling results in subgroup sizes within a sample that are representative of the subgroup sizes within the population. It is equivalent to performing a simple random sample on each subgroup. So let's use the attrition population pandas datasets here. Get the population of employees by education level from attrition population. What do you get? Population of employees by education level. Oh, so we're going to be counting number of employees by education level using the grouping method. Okay. But it says proportion, so that will be in percentage. The attrition population And the education column, education column dot value underscore counts. Normalize will be equal to 2. You can see the population by the company education level. So let's see it here. Proportion of employees by education level. So this is the result. Those by bachelor, master's, college, below college, and doctor. The highest is bachelor's degree holder. The lowest are the doctors. Okay. Use proportional stratified sampling on national population to sample 40% of each education groups, setting the seed to 2022. Okay, let's see that. So we want to proportionally stratify, we want to use proportional stratification sampling on this population. We're going to rotation population. Dot sample. Our frag is going to be equal to 1. We set the random states. Random states to be equal to 2022. And voila, we have our random sampling here. Let's see it here in action. So be to double sure. So okay, we have it already printed already. So this is our random sampling. You can see based on this artificial population that we've done here. Let me just set it. Not edge. We have a little bit of row here. Let's see. We have 5 rows as usual, but a lot of information there to deal with. Oh, the group by. Hold up a minute. In our grouping by, let's get up on the line of code. For 40%. Oh. Okay, hold up a minute. This is saying for 40%. Let's do 0.4. We definitely need to use group by there. Hold up a minute. 0. So proportional certified sampling for 40%. So attrition strats, initial population dot go by the education column. We want to sample 40% of the population. The random seed will be set based on the information here. Is 222. That's not the code now. Then we should have a better result now. Okay, so that was a mistake we did there. That I use certified sampling to get 40% of the population. Just use dot head. Okay, it's making sure I'm not using this line of code for slashing, but that still works fine though. So let's continue. So get the proportion of employee by education level from attrition strats. So we need to get the proportion of employee by education level from attrition strats. Okay, that will be the attrition strats by education level, right? Education